Buddy, these are the notes for Algebra 2 Trig, week number 4, talking about logarithms. And I have a special guest with us today. This is my daughter, Kristen.
Hi.
What grade are you in?
5th.
What's your favorite subject?
My favorite subject is either writing or math.
That first one's not good. We'll go with the second one. So good answer on the second choice. Okay. She's just going to kind of hang out with me and talk about this. So, these notes here, this video, basically this is, for the most part, the same notes and examples that you see in your notes. So you might want to have that in front of you. I just wanted to go through and give you an explanation so you can hear it explained, basically. So, for part 1, we are evaluating logarithms. So, the idea here is that the answer to a logarithm, it's an exponent. And so we basically think about the base of the logarithm, 3, to what power gets us 81. So, Kristen, 3 to what power, oops, I just gave you the answer, is 81. Did you see what that was?
I'm guessing 4.
Oh, you're so smart. Correct. 3 to log base 3 of 81 is 4 because 3 to the 4th power equals 81. So, we're not used to thinking logarithmically, so we usually turn it into logarithm, and turn it into an exponential to help us get that answer, because we're used to thinking exponentially. But that's the idea of what a logarithm is. The answer is a exponent. So the base to the exponent power equals what we're taking the log of. Now, Kristen, do you know what an exponential function is?
No, not at all.
You sure?
Yeah.
Okay, well then listen up. All right, so to rewrite this is a logarithmic expression, right? You know how it says logarithm right here? Or it says log?
Okay.
It's a logarithm expression. It's not like a tree.
Okay.
So, to write it as an exponential function, I like to do a little spiral path. This base of the logarithm is always the base of the exponential. So we're going to take this base. The answer to the logarithm is an exponent, so 3 to the 2nd power equals what we're taking the logarithm of. Kristen, what's 3 squared? Say 9.
9.
Good answer. Okay, go in the opposite direction. We have an exponential function. We are going to write this as a logarithm. The base is always this, base of the exponential is always the same as the base of the logarithm. So it's a log base 4. Remember, the exponent is the answer to the logarithm. So the thing that the exponential equals is the thing we're taking the logarithm of. Right?
Okay.
Good. So, a couple things to remember. When we talk about negative exponents, it does this fraction of 1 over. Some other things with exponents, something to the 0 power is always 1, right, Kristen?
Okay.
Good. Good answer. You should say okay with more confidence. All right. Part 3 of your notes. Finding the inverse. Kristen, do you know what an inverse function is?
Nope.
You sure?
Yep.
Okay. Then listen up. So, inverses, we kind of actually did this today when we were working on fractions. I helped you with that 2/3.
Yeah.
Okay. So, an inverse kind of undoes, if that's a word, what the original function did. So, today we were talking about multiplying, right?
Yes.
Okay. What's the opposite of multiplying?
Dividing.
Okay. Those two things are inverses of each other.
Okay.
So, with logarithms and exponentials, they are inverses of each other. One of them is going to undo what the other one did.
Okay.
So, to find the inverse, what we do is we think about a graph. Inverses are reflections of each other over the line y equals x. Say okay with more confidence. So what we do, when we do that reflection, we switch our x and y coordinates. So f of x is a y. We're going to switch. Changing that to x, so now it's log base 3 of y minus 4. We switched our x and y's. Now we got to solve for y. So we are going to rewrite this logarithm exponentially. So 3 to the power of x equals what, Kristen?
9.
Ah, no, that's 3 squared. 3 to the power of x equals
4.
the y minus 4. You're close with the 4 part. All right, now we got to solve for y. So, what's the opposite of subtracting?
Plus.
Plussing? Good words. Plus 4. All right, so y, when you subtract 4, then add 4, those things cancel out. So you get y equals, you take our
3
3x.
plus 4.
No. You take our 3 to the x, you got to learn your order of operations first. 3 to the power of x, and then we add 4. All right, so we solve for y. Proper notation when we talk about inverses is this. It was function f, so we're taking the inverse of it. So this little negative 1, it looks like it's in the exponent position, has nothing to do with it, it's just notation. Of x equals 3 to the x plus 4. All right. I'm going to make another video. I'm trying to keep them kind of short for parts 4, 5, and 6 of the notes. Thanks, Kristen. Say bye.